Hi guys, today our topic is mechanical springs. Basically, spring is the mechanical components that is used for control of force and torque. They are storing and they store energy and utilize in other forms. Springs are basically classified as wire springs, flat springs, special shaped springs. Wire springs are of two categories: round or square wires. They basically are helical in shape. They are made for tension, compression, or torque. As you can see in the figure, the the force is applied and in both directions. There are two terminologies. The major diameter, capital D, that is from center of this area to center of this area, and small diameter, D, that is basically the thickness of wire. Stresses, you can read the complete theory. I am telling you just the formulas. The tau max is basically torque into the R divided by J and F by A. In the term of our springs, T is equal to FD by 2. F is basically applied force, D is the major diameter, pi is the constant, and D is the thickness of wire, and into the cube, and plus 4F divided by pi D square. There is another term that is called spring index. These are separate for every spring. C index is given by D by D. For most of the spring, C ranges from 6 to 12. We get tau is equal to 2C plus 1 divided by 2C bracket 8FD divided by pi D cube is equal to, which is equal to Ks into 8FD divided by pi D cube. Here Ks is equal to 2C plus 1 divided by 2C. This factor Ks is called shear stress correction factor. Talk about the Ks, that is 2C plus 1 divided by 2C, that is shear stress concentration factor, correction factor, sorry. Now we shift into tau is equal to Kc Ks into 8Fd divided by pi d cube. Here Kc is the curve, because when we applied the force, the curvature is changed or increased or decreased. That is depending upon type of force. And here the Kc is the correction factor of curvature. Now we will substitute Kc, Ks into Kb, which is given by 4c plus 2 divided by 4c minus 3. That is called combined factor Kb. So now tau become Kb into 8Fd divided by pi d cube. Sorry. Similarly, deflection is given by U is equal to T square L by 2 Gj F square L divided by 2 Ag by putting the given values that will be used above. Here N is equal to active number of coils. So U is equal to 4 F square D cube N divided by D small d power 4 into G plus 2 F square D N divided by D square by G. By applying Castigliano theorem, we get the deflection, and here the deflection is by putting all the values. Y is equal to 8Fd cube N divided by small d4 G into the bracket 1 plus 1 divided by 2c square. Here 1 plus 1 divided by 2c is very small, so we can write it as 8Fd cube N divided by d power 4 G. The effect of transverse shear is neglected here. So we know the spring rate K is equal to Fy. So K is equal to d4G divided by 8d cube Na. Here Na is number of active coils. Compression springs are different types: plain end, plain ground ends, square close ends, square or ground ends. These are not the topic of our videos. You can see in the context. So finally we get the L0 value is equal to 2.63 d by alpha. And ultimate tensile strength is given by SUT, that is equal to A by dm, that is here this A by dm. A and m are basically the material constant. You can find it from the tables. And sigma ys is between 0.35 of ultimate strength and 0.52 of S ultimate. And it depends upon strengths, it may be 0.45, 0.5. basically design is first material, then function, type of hands, manufacturing, then safety factor, working range. These are all the factors here. Now we will move toward our context book, guys. And now we are doing how to select the diameter of the spring wire by following method. Here the our task is how to choose D. It depends upon the some free factors that is of our choice that are we select wounded, as wound, set removed, as wound or set. These are formulas of D for the D, SSY, SSY are for the different ones. This is basically the formula for C, that is 2A minus B divided by 4 alpha 4 beta plus square root of 2 alpha minus beta divided by 4 beta whole square minus 3 alpha divided by 4 beta. The capital D, that is the major diameter, is given by SSY, that is strength, yielding strength, and 2 pi small d cube divided by 8 into factor of safety 1 plus zeta into F max, that is maximum force, and zeta is the constant. Alpha is given by SSY divided by NS, and beta is given by 8 into 1 plus zeta F max divided by ND square. Here capital D is given by C into D. This is actually the flow chart by which we solve the numerical problem or select the small diameter. These are again the formulas. C formula, D by D. You can take the screenshot or stop the video here to note the formulas. KB is 4C plus 2 divided by 4C minus 3 tau s. I will tell this previously. And is equal to SSY divided by tau s OD, that is the outer diameter, is D plus D, and inner ID, inner diameter, D minus D. That is, this one is not of actual use. So NA is given by G, that is a constant, a modulus, D4 by max, here D cube, F max, and NT and LS, L0 are given in the different tables, and I will tell you the table. This is basically table number 1. These are the given formulas. You can use the Shigley machine design book for instance. So these are actually the process, and finally the figure of merit is calculated by this. We will go and solve now example. 10.2 in the mechanical Shigley book. I will not read the basic for complete problem because you can find it from your book. I will tell you about some given things, that is here A is equal to 2,01,000 psi, M is equal to 0.145, and E you can find 28.5 psi, G is equal to 11.75 psi, expecting that D greater than 0.64. Ends are square and ground. Function F max is equal to 20 pound, and Y max is equal to 2 inch. Here factor of safety is 1.2. Robust linearity zeta is given by 0.15. SSY is equal to 0.45 of SUT from that we get from table 10.10-6. Design variable, we select first of all, assume that D is equal to 0.080 inch. That is wire gauge number 30 from table A-28. So guys, this is getting from table 10-6. Decision variable is D is equal to 0.080 inch. SSY is equal to, now we will calculate SSY first of all. SSY is equal to 0.45 SUT. We will put in the values 0.45. Actually this SSY is equal to 0.45, so we put 0.45 and put the value of A, that is basically A by dm. So a d is 0.00, that we take assumption, and m is given, that is 0.145. So we will get the value 1,30,455 psi. From figure 10-3, that is from test, alpha is equal to SSY divided by NS. So 1,30,455 and divided by 1.2, we will get the value of alpha, 1,08,713. So now we will find the beta. Beta is given by 8 into 1 plus zeta into f max divided by pi d square. We will put the subsequent values that is given or to be found. The value is 9151.4 psi. Then we will go to C. C is given by 2 alpha minus beta divided by 4 beta plus under root of 2 alpha minus beta divided by 4 beta square minus 3 alpha divided by 4 beta. We will calculate, and the final value is 10.53. Then we will go for D. D is equal to CD. Putting the values, the D is come out to be 0.8424. The next is the B, constant KB. Put the value of C in the formula, that is 4C plus 2 divided by 4C minus 3, and value come out 1.128. Then TS actually the tau S, sorry for my mistake, T is tau S. Then putting the values, it is KB 1.128 multiplied by 8 into 1 plus value of zeta, then f max 20, then d divided by pi small d cube. Its value come out to be 1,08,700 psi. Factor of safety is calculated again, and then it is 1.2. Now we will calculate outer diameter. Outer diameter is given by capital D plus small d. Then value of come out to be 0.923 inch. And A, effective turn, is given by capital G small d power 4 y max 2 divided by 8 into capital D cube, that is 0.43 into f max. So the turns, active turns is 10.05, and that is approximately 10 turns. And now effective turns is given by total turns is given by effective turns plus 2. This is from the formula in table 10.1. 12.05 total turns. Then ls is also from the formula. Its value is nt multiplied by d. Total turns, sorry, my mistake, its value is I'm right, sorry, that is total turns into small d. Then it is 0.964, and L naught is equal to 0.964, that is ls plus 1 plus zeta into 2. That is also from formula. So L naught is equal to 3.264 inch. Now we will find the L critical, that is formula 2.63 into L d minus alpha, d by alpha. So putting the values, this is alpha is not the previous alpha, this is actually from the table. So alpha is 0.5 and value comes to be 4.43. Now we will go for the FOM figure of merit value, that is minus 2.6 pi square small d square total turns into capital D divided by 4. So the value is come out to minus 0.417. So this is from actually assumed diameter. So repeat the above value for the other wire diameters from the table. Easily accomplished with the spreadsheet program. That is a reciprocal way. And then we will apply same method for 0.063, 0.061, 0.067, 0.071, 0.075, 0.80, 0.85, 0.90, and 0.95, and any of the diameter you want for your project. Then all the values come out to be this. And according to the given constraints, that are number of effective turns are less than 15 and must be greater than 3. So some of the constraints are excluded here. Then other is spring index must be greater than 4 and 12. So see, that are excluded. Then diameter ls must be less than or equal to 1. So some of our ls are excluded. Then L not constrained, similarly L critical, and all the values are excluded that are not fit in constraints. Then we will come out to be with only two diameters. Then if there is any other constraint, check for it and select only one of them. So this is basically how to select the thickness of wire for the mechanical spring. This is basically design of the mechanical spring of mechanical engineering design by Shigley for mechanical engineers BS. There is another method of doing the same job that is in spreadsheet. We will go there and tell you about this. Microsoft Excel, we have given the value of A, M, D, and here in the S we put the formula and apply it to all. This is basically the formula. If you don't know how to make formula, then I will there is another video in which I will tell you how to make formula or function in spreadsheet. So the ns value is given, alpha, similarly put formula here, and this is actually zeta given, it is also given, beta is putting the formula. See the biggest formula, it is very difficult because using brackets in correct manner is so much important for the correct value. Then it is d kb, sorry, tau s, the given formula, od, max is given, true, g is also given, 11.75 g mpsi. So number of terms is given by the formula and all the values have come out to be this. Because analytical method is so much long, to repeat all the values in correct manner again and again, it take approximately 4 to 5 hours for one project. But in using spreadsheet, we will do it in maximum 1 to 1 hours. But and there is another benefit, if we make it one time, we will go for any value at any time. So ND has come out to be this. The formula is not in the form of D or X or C or beta, it is in the form of cells, the given cell, column B2, B3, this is like what I will tell you another, you see the another video, you will find how to make formula. LS, M naught, value critical, and FOM value, all the values are included. So all the values are here. This is actually how to do a mechanical spring selection. We will do same procedure, putting the values in that table. The table is here, this table, all the values. Let's see, d is equal to 0.3914, 0. Sorry, so we'll go for 0.95. Then d is 1.427. Go to the Excel sheet, d, capital D, that is, instead d I will write d to 1.426. It is not precise, it is actually more precise than that 426. Here is 427, it is rounded off. So I will conclude video here. If you have any question regarding this, put it in comments. I will answer your comments as soon as possible, or give an email.